This video we're going to look at exponential graphs in a little bit more detail, and we're really, I suppose, looking at translations for exponential graphs. And this is a tricky question, and there's a lot of learning in this, so please make sure that you watch this video slowly, you take notes, you pause it, rewind it if you need to, and you can also use pages 451 and 452 of your textbook, which gives you really good notes on this. So let's just look at a typical exponential function. A typical exponential function is in the form y equals k to the power of x. So y is some number to the power of x. Example of this would be y equals 2x. If you wanted to graph this, you might say, well, what's y when x equals 0? Well, y would be equal to 2 times 0, and anything to the power of 0 is 1. So that gives us our first point on the graph. X is 0 and y is 1. But what you'll find is if you do this for any number k, any value of k, you'll get the same answer. Y equals, not the same answer, or yeah, you'll get the same answer, sorry. Y equals 7 to the power of x. Well, when x is 0, y equals 7 to the power of 0. Any number to the power of 0 equals 1. So you have the coordinates x is 0 and y is 1. So that's one rule that you need to know about exponential functions in this form. If the exponential function is y equals some number to the power of x, it must pass through the point, that's the dog making noise beside me there, the point 0, 1, well, the point 0, 1. And you can see that on this graph. But no matter what the value of k is, it will always pass through this point. So that's the first thing you want to learn. Now let's look at different forms of this equation. So we have y equals k to the power of x. What about if we have y equals some number multiplied by k to the power of x? So an example for this might be y equals not just 2 to the power of x, but 2 times 2 to the power of x. Now let x equal 0. For when x equals 0, y equals 2 times 2 to the power of 0, which is 2 times 1, because anything to the power of 0 is 1, y equals 2. So our point is 0, 2. Let's try y equals 3 to the power of 3 multiplied by 2 to the power of x. And in this case, you'll get 3 times 2 to the power of 0. So when x is 0, sorry I didn't say that, when x is 0, y equals 3. So our next point is 0, 3. Now there's a pattern here that emerges. In the last function, here the black line, every function went through the point 0, 1. If you put a 2 in front of that, the function goes through the point 2, 0, or 0, 2. If you put a 3 in front of the 2 to the power of x, it goes through the point 0, 3. So what you notice is, let's say this is y equals 3 to the power of x. What you notice is every value is being multiplied by whatever number is in front of it here. So for example, let's look at in the first function when y equals 2x. When x equals 1, y equals 2. But if we put a 2 in front of that 2 to the power of x, this output value, this 2, gets multiplied by 2 and becomes 4. So really, whatever y value, all y values or output values are multiplied. Stop it. The dog is moaning here beside me. Come here. Come here. Whoa. Are multiplied by a. I hope that makes sense. That's a little bit confusing there, but basically if you read pages 451 and 452, it might make it be a bit clearer. But basically any y value, if you just had this y equals k to the power of x, and you got the function, let's say you got one point was 2, 7, and then you had y equals 3 to the power of kx. Well, your y value gets multiplied by this number, this 3. So this would become 221 because the y value gets multiplied by whatever number is there. If there was a 4 in front of the k here, it would be 4 times 7 to give you 28. Next one. This one is when we have a function in the form of y equals k to the power of x plus b. So again, let's use our example. Y equals 2 to the power of x, and let's say plus 1. So when x equals 0, y equals 2 to the power of 0 plus 1, y equals 1 plus 1, y equals 2. So when x is 0, y is 2. When x is 0, y is 2. Let's look at y equals 2 to the power of x plus 2. X is 0, y equals 2 to the power of 0 plus 2, which equals 1 plus 2, which equals 3. So that coordinate is 0, 3, this point here. Now what's the pattern here? Because you can always test this in exam, you can always play around with the numbers and see what happens. But what you notice here is every output value gets increased by 1. So if we have a function and we add a letter here, so it becomes plus 1. In this case, if our example is plus 1, all y values, our outputs, are shifted upwards by b. So I'll explain that again once more. If this plus b, if we decide to have a plus 1, when you look at your graph, every single value gets moved up 1. And what I remember, I'm always comparing this to if I just have y to the power of 2x, and then if I have y to the power of 2x plus 1, every single value just moves up by 1. If I had y equals 2 to the power of x plus 3, well, what do you think would happen? All of these values would move up by 1, 2, 3. 1, 2, 3. 1, 2, 3. So your graph would be up here. So if that, whatever that number is, basically the graph has moved up that amount of places. What do you think would happen if we didn't have plus b, if we had minus b? Well, in that case, you'd have the opposite effect. You wouldn't move up by 1 or by 2 or by 3, you'd move down by 1 or by 2 or by 3. Now remember, you can learn these rules, but you don't actually really have to learn them because you can play around with functions and you can always find points on the function by just putting in values of x and y. Last one. What if we have a function y equals k to the power of x plus another number h, but this is in the exponent? So an example of this would be y equals 2 to the power of x plus 1, but the plus 1 is in the exponent. You could also have y equals 2 to the power of x minus 1. So this could be a plus or minus. Now if this is the case, if this is the form, that h number there, and I'll just tell you here rather than working through it, if whatever that number is, the output values are shifted to the left by h places. And you'll see this on the graph here, hopefully. So here we have y equals 2x, 2 to the power of x. Here we have 2 to the power of x plus 1. But when x is 0, y is 1 on the black graph. But if we add this plus 1 here, it's shifted one place to the left and it becomes minus 1. On our black line graph, when x is 1, y is 2. But if we have 2x power minus 1, it's shifted one place to the left. So all y values are shifted one place to the left. If you have y equals 2 to the power of x minus h, so instead of this being a plus, instead of this being a plus here, it becomes a minus. what happens here is all output values are shifted to the right h places. So on a black graph it's here for y equals 2 to the power of x, but if we add this minus 1 here, we go one place to the right, one place to the right. So all of the bits that I've kind of circled, all of the sentences that I've circled are the rules that you need to learn. As I said, they're in your book and they are complicated. This is tricky. So take your time watching this video, pause it, rewind it, watch it again, read the notes in the book, and when you see some of the questions and you look at some of the answers, you'll start to figure out the pattern yourself. So don't be afraid to ask me any questions on the thread as well on Teams.